All right, example from the homework, breaking down the steps of finding an inverse function. So in order to use the inverse function theorem, you have to know both the function and its inverse. And so sometimes we just know it based on past life experience. Other times we got to figure it out. So in this case, we got to figure it out. So here we're saying f is going to be g inverse of x. And so I need to make sure I know all of my functions. And I'm given g of x, but I'm not given the inverse. So I'm going to find the inverse. So to find an inverse, you first switch x with y. So instead of y equals x plus 3 over x, we're going to write x equals y plus 3 over y. And then we have to solve this for y. So again, to find an inverse function, you switch variables. And then you solve for y. It's one of two techniques. Oops, y. So let's see, to solve for y, I have y's on the same side. There's a few ways to go about this. Often we would multiply the y to the other side, so that should work too, but instead I'm going to view this as y over y plus 3 over y. Y over y is just 1, so now I get x equals 1 plus 3 over y. So now I only have one y hanging out. So then I'll subtract the 1 to the other side. And then I can flip both sides so that it can be 1 over x minus 1 equals y over 3. And then I just multiply the 3 to the other side. So I get y equals 3 over x minus 1. So that would be the inverse function. So this is what we're calling f of x, which is also g inverse of x. So I now know g inverse of x. Next thing I'm going to do is I'm going to find f prime of x. And again, this is my f right there. Right? So this was step 1. If I didn't know the inverse already, I had to find it. Now, in the other examples I gave, I already knew the inverse, so I was pretty much starting at this step right here. So f prime of x, let's use the quotient rule on that. Quotient rule says take the derivative of the numerator, which is 0, times the denominator, minus the numerator, times the derivative of the denominator. Derivative of x minus 1 is just 1, all divided by the denominator squared, which is, let's see, negative 3 over x minus 1 squared. So that's the derivative of this inverse function. And remember, these functions are inverses of each other. So step 2 is right here. Step 3 would be to say, okay, take that derivative and plug in g of x instead of x. All right, so that means for my negative 3 over parentheses squared, I want to drop in, instead of just an x there, the formula for g of x, which is the x plus 3 over x. Drops in there, and then we want to clean that up with a little algebra. So let's see. That's going to give me negative 3 over x plus 3 over x minus 1. We could view that minus 1 as x over x. So I have x minus 3 over x minus x over x. And let's see, x minus 3 minus x is just minus 3. So now I have minus 3 over x in the denominator squared. And then we can multiply by the reciprocal there. So that's going to be minus 3 times x squared over minus 3 squared. And that's going to be positive. That stays negative. So it looks like I get x squared over 3. Negative. That's right. Step 4 is to then just flip that, if you want to break it down. So step 4 would be to flip that, so if I take the reciprocal of that, 1 over negative x squared over 3, that becomes, say, negative 3 over x squared. And that should then be the derivative of the inverse of f of x, which is g of x, right there. Now, we could check that to see if that's really true. So that's just applying the inverse function theorem. And you could have done that in 2 steps instead of 4 like this. But I do have to know, if I know the function, I do have to know its inverse in order to use the inverse function theorem. We need both of those. So to check that that's really the right one, we could apply the quotient rule here. Quotient rule on this one says take the derivative of the top, derivative of x plus 3 is just 1 times the bottom, minus the top, x plus 3, times the derivative of the bottom, derivative of x is just 1, all divided by the denominator squared. And in the numerator here, I get x minus 3. Which is equal to negative 3 over x squared. Now, in this case, applying the quotient rule is actually a little bit easier. The point of this problem was to get used to having a function and its inverse and applying this inverse function derivative formula right there. That was the main point of it, which means you're going to get some exercise in your algebra skills. So I think this section is 2 things. 1, we have this new formula, and then 2, can you apply the formula, which means you have to do some composition of functions in order that happen. In some cases, I have to do a lot of kind of ordinary algebra. In other cases, I've got to do some fancy trigonometric algebra based on a right triangle. So that's some deep stuff right there. But fun.